We're live. I'm solving LeetCode problems. Algorithms and data structures. We're doing this problem. Check this out. This is a first 100 problem. It's one number 77. Combinations. And I'm wearing this hat. Hopefully it will help me do it in 30 minutes or 40 minutes. So it's from the top 150 interview list. Top interview 150. Let's get to it. Given two integers n and k, return all possible combinations of k numbers chosen from the range of 1 to n. Combinations of k numbers. You may return the answer in any order. Any order usually suggests hash map. Okay. Example 1. N is 4, k is 2. 1, 2, 1, 3, 1, 4. So 2, 3, 4. Then 2, 3, 2, 4. 2, 3, 2, 4. Oh. Do I understand anything here? 3, 4. There are 4. Choose 2 equals 6. Total combinations. Probably plus 2, I don't know. Know that combinations are unordered. And that is 1, 2, and 2, 1 are considered to be the same combinations. And 1, k, it was 1, output 1. There is 1, choose 1. 4, choose 2. So it's, I understand what 4, choose 2 equals 6. I don't understand that language. Constraints. N is 1 from 1 to 20 inclusive. K is from 1 to n inclusive. Let me just try to understand it. If we can do that, we're halfway there. So I didn't understand why there is not this 2, 2, and 2 combination here. There are all possible combinations of k numbers. K is 2. Chosen from the range 1 to n. K is 2. Of k. Oh, I see now. Okay, yeah, so there are 2 numbers here, and we can choose any of the 4 numbers. There are 4. Choose 2. Oh, we cannot repeat them. So, I mean, if we take here 1, we can pick any other. Yeah, so there are 4, choose 2. I think I'm slowly getting it. So 5 minutes to kind of understand it. So that means if we take 1, we can only take 2, or we can take like 2, 3, or 4 is the other one. That's why we have these combinations, 2, 3, or 4. We take 2, we can take 1, 3, or 4, but 1 is already been with 2, so there is 3 or 4. If we pick 3, there is only, so basically we have this pool of numbers to choose, and we can build a tree that could start with 1 could start with 2, 3, and 4. And the depth of it is, in this case, is up to 2. But like with 1, for example, with 1 we can have 2, 3, 4, but then if we have that, I mean, not like that, it's gonna be one of these, 3 or 4. But with 2, we can pick all others excluding 1, because 1 has already been, so it's, and excluding itself, 4. And with 3, we can pick also 4, right? Right, and but with 4, we have already had all the combinations with 4. Right? 4 with all others. So I'm looking if we can do some kind of traversal, or the search. We can build a tree with that. We can do a search with it. But these essentially will be all different results, but I mean, these are possible trees, because if the length could be up to n, so it could be actually longer, like it could be 3, and then that means we'll get another like 1 with 2, and then we have what we have left is like 2, 3. We have left 3 and 4 for this specific one. But then yeah, for 3 we already have with 2. That's kind of one of the tricks here. Like if we know 1, 2, 3, and 1, 2, 4. Okay. Yeah, we're doing an example with k is 3. So 1 with 3. Mm-hmm. One with 3. How do we know that we already tried 1, 2, 3, so we don't do 1, 3, 2? That's kind of, because we could n is so if we're n is 4. Is 4. That gives us 1, 2, 3, 4. Yeah, if we knew, if we go in order, and then we hit like 1 and 2. Well, we don't go back basically because back we already have covered those with 2. Yeah, we can only go forward. So that's why. Then so with 2 we only go forward 2, 3, but then with 3 yeah, and it has to be key numbers, not less than key numbers. Yeah, all possible combinations. Yeah, we got to build them. So with 1 and yeah, let's just 1. We'll do 1 and 4. That's the last one, so we can't do anything because 1, 3, 4 is done. 1, 2, 4 is done. So yeah, no other. We can't complete it. And then there's 2. There's 2. There's 2, 3, 4. But yeah, 2, 4 already been used. 2, 4 with 1, 2, 4 with 3. So and 3, 4 also. So that means 4 combinations, right? Yeah, but the basic case, that one was this. This was just 2. It was 1, 2, 1, 3, 1, 1, 4. Then it was 2. Yeah, we don't go back, so it's 2, 3, and we go forward only. 2, 4. Yeah. Then it's 3, 4, and that's it. So that gives us 6. 1, 2, 1, 4. Yeah. 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 Well, there is a pattern. And there is a pattern. But they could be up to 20, right? So now I'm thinking iterative or recursive, because there could be an iterative solution here. Like we could just for each n, yeah, for each n, we could just do for range n, but we actually need the numbers now. We need the number for is 1, I is less or equal n, I plus plus. Then we'll have for j is 1, k plus. So this is sort of a brute force, and we will just check. Yeah, we will just go until we'll build a slice. Yeah, we need result is slice of slices of integers, and on each one we'll create this combination. It's a slice of integers, and we will say well, it's probably going to be the other way, yeah. K times, yeah, we'll need this K times. And so the first level will be iterating. Oh, actually, there will be K levels, right? So K digits, in this case 2. In this case 2. It's just 2. And in the first one, we will start. Oh, because we want to build like 1, and then go and go add 2. So we need so that's why I'm like for 1, we need to try 2, 3, and 4. For each n, for each n, or for each, for 1, we'll say that combination is append combination and this j. What next? We want so for this, we want to start building for this. We want to start building. I'm thinking maybe backtracking could be better. Although we kind of know how much we need to go until we have this. Yes, we just want to continue that, simulate that pattern, implement it. And so k times, we want to take a number from the pool, then next time we'll take the next number from the pool, take the next number from the pool. So basically, it looks like we need an iterator that gives us, next number. And then we want to sort of restart it. Do we restart it ever? Oh yeah, in this case 2, 3. So I feel like the recursive solution makes a little more sense here. Gosh, I pressed by accident. So, and by the way, Yeah, so we have this pool of numbers. Or instead of storing them, we can just store them. The range will be this. The range is from 1 to n. Yeah, that's our range. And we want to take a function. Probably going to be DFS. A function that takes range. That takes range and might not even need to return anything. Because it will be building well, it will be adding something to a slice. We'll have one slice where we'll be collecting those combinations. Yeah, so combination is a slice. I mean, we can pass it as well, but do we really need to? So, okay, so we have this function. We stop. Here's what we stop at. If length of com is n, is k, then we result and com. We need to copy it. Yeah, we need to copy. Actually, there is the slices. Clone, I think it's like that. Yeah, we'll try it, but yeah, so we'll clone the slice and append it. So we'll call DFS with range. Is that what we want, the range? Call it a pool of numbers. Because what we want, we'll see. Call DFS with the range and return result. But so that's where we kind of return, but if it's not full yet, then we will have a recursive call at some point. So basically, yeah, initially comb is 0. So we're ready to add the first number. And we're gonna do it. We'll say that comb is append comb, and we need to get that first number. It will be the first one in the range. Yeah, the range right now is from 1, so we need to get the first one in the range. Well, the first one in the range is actually, do we actually need a range? We know n, so we don't need a range. We just need the digit is 1. Okay, well, current is 1, and append current. Yeah, we don't need the range. It's current. Then we say, okay, so now we have the combination that has 1. And then we'll call DFS with current plus 1. And here we have to say comb is comb without the length of comb, without the last one. So we added, and but here's the deal. We need to have these calls for each. But we also need another check. We need to check that our iterator doesn't go, if current we also need to make sure that in other base cases, because if we already at 4, we are already at 4, the last one, yes, we might add it, but we're not gonna add call more. We might append it here. So with 5, if cur is less than n, then we call it. Otherwise, we just don't call it. Right. So result. we flush, and by the way, once we append it, so that call happened, yeah, we come back. But we need these calls to happen to each, basically each current. So for num is 1, num less, as long as num is less than n, because, well, k could be 1. If k is 1, then we do need to go, yeah. And num plus plus. So we call it for this num. Yeah. So we'll start each tree from each one, and then start with 1. Once the length is k, by the way, this doesn't add any numbers, doesn't append them. So yeah. Current equal n. Yeah, if it's the last one, we still need to call it, right? Yeah, I'm thinking about this scenario. So we have the last one, and current is the last one, like before. But we're here 1, so it's not case 1. So we add, and we need to call DFS again. So after this flush, we need to cover, yeah, with the 4 is added. And it's the last one. It's 4. So for 4, we will call, yeah. Current is 4. We will try to call it for 5. Well, current is 4. We'll flush it 1, 4. We'll go back to the previous. Yeah, we're at 1. Yeah, we'll remove. So because this will be just adding each n, and so it will do a call for 5, and at 2 it will flush it with, but so it will call, DFS will hit, but 5 will not be. Will 5 be added? The call for 5 will happen with call for when we are here again at 1. Current is 4. Oh no. Wait a minute, this is not what's happening. The thing is, so let's just understand. It will this will call for 1. Okay. Length 1. This will call for 2. So 1 is added here, yeah. This will call for, with current becomes 2. Length is still 1. So 2 is added. Current is 2. We're calling DFS again. Now it's length. Now it's length 2, and we were flushing and returning it. So that DFS returns. That's been flushed. That DFS returns. Comp is being cut back. So we need that call happen not just for current plus 1. We need that call to happen for a range. Yeah, for current equals, or for I equals current I equals current I less or equals n I plus plus, we need to call so we need to call for 2. Actually, current is 1. But we need to start with current plus 1. And I'm thinking maybe if we start with an empty slice, we don't add anything here. If we only add there, we might even not need to do this, because if we are doing those repetitions all the time, so so we have a DFS, and in that DFS call, first we check, do we need to flash it? If we do, okay, then flash it and return. Okay, if we don't, then let's start building it. Okay, so what we do is we work with a range that starts with current, which is 1, and goes until m. And so we append that first num, first num. It's a num, yeah. So, and we call the fast for the next one. So now if now the length is 1, and we update the range. So next call will start with 2. So 2 is appended. And it's called for next call will start with 2. Yeah. And so 2 is appended. We call DFS for current is 3, but we're ready to flush, and we just return back, and we return our count to 1. Which needs to happen here. And then the next num yeah, so we had 2 that has been appended. Now we have again 1. Now we need to take, okay, so now we have again 1. We are at 1, yeah. But num is now 3, right? Num was, initially num was 1, and num became 2. Now num is 3. We are appending 3. So for the next, here is the deal. We need with curve. We need to num, to pass the num. So and drag back. Now we're 3. Num again. Oh, wait a second. Who appends 1 again? We need to so when, well, 1 was, we just tracked back, so 1 is there. We clone, we appended the clone, now with 4. So now, we're in the loop, just calling for those flushes, and now finally num hits n, which is 4, and after 4 we're done with the loop, and we're going where we are returning. And initially we added 1. And we were doing this for, so 2, 3, we're returning. Now we're back to empty. Empty. This should be working because now we're back to empty and we're at 2. And none starts. Num is 2 now. Okay. We're appending 2. And we're calling for 3. Yeah, it should be working. I think we can try it. Oh, oops. Yeah. At least this test cases. Let's see if it works on all the test cases. Let's see, it's taking too long. It worked. Yep, Baroni, so 15 minutes, but we did solve it. Medium level problem. DFS to do these combinations. Yay. So, I mean, I'm pretty sure there are some ways to like optimize this, but so far this submission looks so by the way, submissions 15 minutes. It's not bad in terms of runtime and memory. And it's it is a interview format, not too long. I mean, not too much code. So solve medium level problems solved within, well, around 50 minutes. 51. I would say maybe a little too long, but that's much closer to a target time. So this hat is helping. Thank you for watching. Like and subscribe, and we'll see you in the next video.